last 2 years. So we can imagine that how much data we are going to generate and how much opportunity that we can have if we know how to play around data and make some business value out of it, right? So if you just look around, around the room, you will find lots of data around you, and which you take it for granted, right? If you look at your tablets or smartphones, PCs, Internet of Things devices, sensors, all over the place. Like even if you go and watch TV over Netflix, they are reading your pattern of series that you watch, and they try to recommend the right series, for in the upcoming days. So all these companies and all the industry, what they essentially are doing is they are just trying to make best use of this data. It was not that this data was not available. It was available, but it was not available this easily, and there were not much instruments available at that time, maybe 10, 20 years back, to capture those data. All right, but now we have this data, and if you notice, you will find there are a lot of companies who are completely built on data, right? So as a data engineer, it's always valuable to understand and learn how you can make use of this data and make something meaningful out of it. Now, when we talk about data, we typically divide this into 3 different types. Although there is a very thin line between a few, unstructured and semi-structured, but basically, structured data are the data which you see in a row and column format, or in a structural database like RDBMS or MySQL and so on, or Oracle for that matter. So those are like you define the schema and you then put the data in, right? So those are very structured. You can run join queries, you can run complex queries, and so on. And then there is another type of data that we have is called unstructured data. So just like the name suggests, it can be any data which is not relational, in the sense it could be documents, PDF file, image, PNG files, media files, and so on. Now, if you look at any of the application that today, let's take an example. When you go and open a bank account these days, you don't even have to go to banks to open a bank account, right? So if you have heard of neo banks in India, the way that you can open a bank account is through your smartphone. Now, when you look at that application, you will see that the data that they are taking from you to create an account, it is completely unstructured. It is not just like you need to give your name, date of birth, age, and so on. Those are always there. But along with that, they will take your fingerprints. They will take your, maybe a voter card or Aadhaar card, your photograph in soft copy, and so on. So if you look at it, that whole data that was captured by the bank to create an account is very much unstructured. It has, it has some structural data in the sense of name, address, phone number, and so on. Then it has some, documents attached to it, like Aadhaar card, photocopy, or voter ID card. And then it has some media files like, let's say, your image, and so on, right? So it's not exactly a media file, but you get the idea, right? So you have a mix of all different types of data, and they all are going into some place, right? And imagine that if you have used different database for saving your data for relational data in a relational database, and saving some part of data in some NoSQL database, and some part of data in some other file system, it would have been very difficult for that application to read and write data on that, right? So am I still audible?
Yes, sir, you're audible.
Okay. Okay.
Yes, you're audible.
All right. Yeah. So the the point that I was trying to make is to understand how to manage unstructured data is very important in today's world, because most of the data that we get are in unstructured format. And then we have semi-structured data, which is more like a JSON, XML, or CS, files which you can read the data using some libraries, and then you can create some structure around that. But still, you have to parse that data. But it is still structured, so you can still read the data using some using some pattern or parameters. Now, when you look at this, all these different types of data, and what we see at AWS is, and what we recommend our customers is, it's always good to dump all your data in a central repository. As I was discussing before, that if you have this data at different places, it would be very difficult for different application to read and analyze that data. So it's always good idea where you can just put all your data in a central repository, and you can make your application read from that particular repository and do different things based on your requirement. Now, what is this data lake about? So data lake is a term. Basically, it's a design practice. It's not a service as say, but it's kind of a methodology, or you can say as a design practice. So what it essentially means is you keep all the data at one place, and you can have different types of data, different formats of data. And the important part is, this place will provide you a very fast ingestion capability. That means, you can dump as much as data as possible, and there won't be much of your scale or performance issue, and you can just read whenever you need, or you can just write, or you can just update your data whenever you need. And one of the most important thing is it is based on schema on read. So what that means is, in typical relational database, you have to first define the schema, and then you have to write the data. But here it's not like that. It's like you just dump the data, and then your application, or there are different services that we have on AWS, which can just read that data and understand the schema. So you don't have to spend time on learning the pattern, or learning the schema of your data. Okay, so it can be done dynamically for different applications on the same data. And the most important part is, when you are centralizing all of your data, like let's say if you put all your data in one place, and you have all different types of data, let's say CSV file, XML file, JSON file, and all of that, and you have different applications, and all these applications need to make use of this data. So this might be your sales team, this might be your engineering team, this might be your HR team, and they all want to access this data to make some analysis on that. Now, if you look at this architecture, we have actually segregated the storage piece with respect to this compute pieces around, right? And it decouples, it's kind of a decoupled architecture, and this helps you to scale these application independent of this storage, right? If you have bounded the storage with all this application, there are two disadvantages in that architecture. One is you will need to copy the same set of data in all of these applications, right? All of these compute systems, and also it would be deduplicate. I mean, it will have some duplication, right? And in case of scale, if you need to expand the storage, you need to expand the whole unit with compute, right? So that's why we always try to decouple the storage and the compute, and this can be achieved when you design your architecture, or design your environment with data lake in mind. Okay, and we are going to see what are the services that comprises of data lake. Now, when you think about the whole data pipeline, and this is something that we have seen in the previous section, and in just a different format, but the idea is, you will have some data source which will give you the data, and then you should have the capability to take those data and store that data, and then process it, and then make that analysis used by some other application, right? So that you can ultimately take some business decision. Now, if you start off with the data sources, it could be different. It could be anything like web logs, or clickstream data, any connected device or IoT device, or even Dynamodb, right? So as a data engineer, you should have a basic understanding of all these different types of sources, and this is not at all an exhaustive list, but these are a few of the important data sources. Now, it's worth spending a little bit of time on Dynamodb, because that is one of the important services that we have, which you should think about whenever you think about NoSQL data. So DynamoDB is actually a fully managed multi-region and a multi-master database, and it's basically a NoSQL database. It doesn't have any schema as such, and you need to you just need to create a table. You don't have to define a database because you don't care about the infrastructure, and that's why we say that these all are managed services. And all you have to do is you just have to go and start creating a table and put items in that. Okay, so in DynamoDB every element is termed as items. So if you have 100 items, you can think of it as 100 elements in your DynamoDB table, right? And it's pretty fast, and the reason that it is very fast is because it uses something called hash maps. So what happens is so whenever let's say you have we can have a session on DynamoDB deep dive at later point in time, because it's quite a complex service internally. But to give you an intuition of why we say that this is a single digit millisecond latency that you can get consistently with DynamoDB is because of some reason. So what we mean by consistent single digit millisecond latency is if you take performance and if you take the size of the database, let's say this size and this is the performance. In a relational database, you will see that when the size is small, the performance is quite high. And when the size increases, the performance goes down, down and down, right? Whereas in DynamoDB, what happens is you will get a consistent performance across the scale. So across the capacity or the whole size of the database. Okay, and how we achieve this is because the way that we store the data internally in our backend. Okay, so we use something called hash. So basically in DynamoDB, we have something called a primary key. Okay, so just like any other database, but it is a little different than a primary key that you know in a RDBMS or any relational database. But the idea is once an item enters the DynamoDB, okay, and DynamoDB understand what is this primary key, and then it takes this primary key and it parts that into a hash function, and this hash function gives the exact address of the storage unit that it should store that data. Okay, so that means that in the back end, let's say there are 100 nodes where it stores the data for this DynamoDB table. And based on this hash, it may say that, okay, this is data should reside in, let's say, partition 2. And when the next, this is, let's say, item 1. Let's say the next item is item 2. When it again is fed to DynamoDB, it will find what is the primary key. And based on that, it will use the hash function and it will say that, okay, now this data should go to this, this storage node. So if you look at this architecture, if anyone at the later point in time wants to read item number 2, it can just check the hash value and it can just read the data from the right storage node from the backend. So basically, it is it's O of 1. Basically, if you think about the time complexity, it's very constant, right? So it's always fixed, and that's why we say that as the scale increases, the database performance remains consistent. Okay, so that is something which is good about DynamoDB. And of course, it has in-memory caching, and it also supports streams. So this is something that we started to support recently. So what streams means is, let's say you have a DynamoDB table, right? And let's say you entered one item. So let's say item number 1, and it can have, since it's NoSQL, it can have various attributes, provided that it has at least the primary key attribute, right? That is mandatory, so that it can identify within a table. Primary key identifies an item uniquely, right? So it need to have pass that primary key. So when an item enters the DynamoDB table, let's say this is the first entry into the DynamoDB table, and what streams says is the moment an item gets updated, if you want to take some action, let's say you want to trigger some Lambda function. Okay, we will discuss about Lambda function later point, but imagine that Lambda function is just one more task that is related to this entry of data. So if you want to resonate that with some practical example, let's say you go to a shopping mall, let's say H&M or pantaloons, anywhere, and the first thing that these days people will ask you is, do you have membership? If not, then they just ask you about your phone number, name, and all of that, and suddenly they will ask you about you will receive an OTP. Can you just give me the OTP? So what might you can just replicate that in this example, that this item is nothing but your data that the receptionist was entering, and that might have gone to the backend as a Dynamodb entry, and that has triggered one Lambda function which will maybe triggering some SNS, and a topic, and then it will trigger some SMS to you. Okay, so this whole pipeline can be very complex, and it is not that simple, but I just wanted to give you some intuition of how streams can be used when you have to take some action based on the item entry or item deletion or any activity that happens in your DynamoDB table. Okay, so that is something that you should know, that DynamoDB supports streams. Okay. Now, once that ingestion gets over, the data store gets over, this is the first phase. The next phase is the ingestion. So ingestion means, now the data is coming. Now you need to store that data or analyze the, have some service which can take the data in real time, right? It's not in batches and all. You need to consume the data in real time. Example would be like logs or maybe CCTV footage or camera stream and so on. So we have different services like a database migration service, AWS Snowball, MSK, and so on. But one of the most important service that we should learn is about Amazon Kinesis. So this is a very exhaustive service, and we are going to discuss that now. So Amazon Kinesis is a fully managed alternative of Apache Kafka. So if you have used Apache Kafka, it's kind of an Amazon version of Apache Kafka with lots of nuts and bolts. So you can play around that, and it's pretty fast. Now, this is very good for all of these applications which we just mentioned, of application log, IoT devices, clickstream, where you just think about it. Whenever you see that your application need to analyze data which is getting generated every second, every minute, you can think about Kinesis in the pipeline. Okay, so this is completely real time. That means, as the data comes in, you should be able to read that data. And, as just like any other services, we replicate it synchronously across different AZs within the region. So you don't have to worry about, the durability of the data that, that we get within Kinesis. So now we are going to, see a little bit more about Kinesis. Like, Kinesis is a family of services which has different components, or different services rather. One is Kinesis Data Stream, which is for real-time data ingestion, and then we have something called Kinesis Data Firehose, which is again a serverless offering in terms of data analysis, but this is not real-time. This is kind of a near real-time, because it has a minimum buffers time of 60 seconds. Okay, so data can be used once the data is there for 60 seconds. So basically, it uses a buffer which is capped in terms of time and the buffer size. Okay, so let's say the buffer size is, let's say, 5 MB. Okay, so whichever threshold hits first, after that only you can read the data from the Kinesis Data Firehose. So it's not a real time, but the advantage of Kinesis Data Firehose is it can push the data to S3, to Redshift, to other services like EMR and so on. So we are going to use Kinesis in our demo, but the idea about Kinesis is you can take the data, you can transform the data, you can trigger some Lambda function inside that, and then ultimately you can save that data in different services like either in S3 or Splunk or Redshift and so on. And then we have Amazon Kinesis Data Analytics. So Amazon Kinesis Data Analytics is it's mostly used in conjunction with the data stream, where if you want to analyze some data as the data is coming. So let's say data is coming every second, and now you want to run some SQL query. So you can run some SQL query on that data which is coming. So you're not storing the data anywhere. It's still in the Kinesis data stream, but you want to run some query on that. Okay, so that is something what Kinesis Data Analysis offers you. And then we have video stream. So as the name suggests, Kinesis video stream is used for analyzing the video feed. So if you have a CCTV camera in some, street or traffic signal or airport, you can think about Kinesis video stream. Now, if you look at all these three services, the way that it typically people use in their environment is you will have some ingestion from clickstream IoT devices to Kinesis data stream, and then you may like to use data analytics to run some SQL query as the data is coming, and then you can ultimately use Firehose to push the data to S3, Redshift, or Elasticsearch, or Splunk, or there are other third-party tools available like New Relic and so on. And we are going to see that in the demo. So you will get you can appreciate more about the value add of this Kinesis data Firehose, because there are a lot of things that you can do in terms of transformation and conversion of format and so on within Firehose, and we are going to see that in some time. Now, one last thing is how Kinesis actually works. So if you look at it, the way that Kinesis work is your stream is made of different shards. Okay, so the way that you can think about shard is kind of different partitions, and you are built based on those different partitions. And you can always have 1 shard, 2 shard, 3 shard, and based on your workload, you can also resize your shard, or you can merge your shards. So it's always dynamic, but if you change the number of shards, it takes time for you to change it back from, let's say, 2 shards to, let's say, 4 shards, or 4 shards to, let's say, back to 2 shards. It takes some time, and we have some limit on, how frequently you can change. But idea is you can always, play around with number of shards, and you are built, per shard. Now, if you look at it, how this shard would look like is you will have some producer. Producer means this is the source of the data, like IoT data, or you are pushing the data through some Python SDK, or you are pushing the data through, let's say, as maybe Kinesis CLI client, or so on. So it's basically data. The producer is, you can think of it as someone who is generating the data. And then it comes to Kinesis, and let's say in the Kinesis, it observes that this particular stream has let's say 2 shards. Okay, and what this producer would do is it will split the data into 2 shards. Okay, and it will try to stream it through shard 1 and shard 2, and all the data are actually in order in every shard. So it is not ordered in the whole stream. So let's say data 1, 2, 3, 4, it is coming in this sequence. So it might so happen that you have 1 and 4 here, and 2 and 3 here. So the order is maintained within this shard. Okay, order is not maintained across the shard. So this is something that we can remember. Although this is not that important to you, for you and for your application, but you should understand that how data gets cascaded or injected inside the Kinesis stream. So one important thing is, once the data is inside the shard or inside this Kinesis data stream, you cannot modify that. You cannot delete that data. It's completely immutable. So, and that makes sense as well, right? So as a human, you are not allowed to tamper your online streaming data, right? So, and that makes complete sense when you think about security and all, all the privacy guidelines. So you push the data, and the data remains within the Kinesis stream with a minimum time frame of 24 hours and maximum to 1 year. Okay, so this 1 year was a recent change. Earlier it was, I guess, 7 days, if I'm not wrong. Maybe Rohini can correct me, but I guess it was 7 days, but now it is 1 year. So basically, once the data comes to your stream, you can use that data through your consumer for that entire period. So starting from 24 hours to 1 year, based on your configuration that you have created when you created this data stream. Okay, and it's not only one consumer. Your data can be used by multiple consumer, and now you can think about this multiple consumer as a different applications. All right, and all can use the same set of data, but for their own different use cases. Okay, so now one advantage that you can see here is you're not duplicating the data for different applications, right? And all can make use of the same data which is coming online. So once that is done, once you get that data through Kinesis data stream or Firehose or whatever, you need to store that data. And this is what that data lake thing that will come up, which we just discussed some time back, where we just dump all the data. And the core of data lake is Amazon S3, which is our simple storage service, where you can put any data of any format, like it can be an unstructured data, semi-structured data, or a structured data like CSV or Parquet or so on, right? And it's very highly durable. It provides 11 nines of availability, and we place the data across different AZs within the region. So it's very fast, and it's API friendly. You can read write data through API, and you can think of S3 as the core of data lake, where you will just dump all your data, and then you will read from different services. And S3 provides different types of storage. One is standard, which is the default one, and then you have infrequent access, and then you have something called S3 Glacier. So these all are of, you can think of it as a different tiers of storage, which gives you different performance. So it might so happen that once the data come in, you want to save it in S3 standard, and then maybe after 7 days, once the data becomes a little infrequent, you want to move that data to infrequent access storage class. And then let's say after 1 month, you can move that data to, let's say, Amazon Glacier, S3 Glacier. So all these automation, movement of data can be automated through something called lifecycle management, which is there in within S3 service. But you should understand that S3 provides different classes of storage, and you can pick the class which suits your application the best. And once that data is there in S3, the next thing that you would try to do is you would try to understand or catalog that data, right? So remember that we were saying that it does schema on read. So you can resonate that with Glue, where you just have dumped your data. We don't know what is the schema, what is there inside that data. And now you are telling AWS Glue that, hey, can you just, crawl through this data, which I have under this S3 bucket, and tell me that if you can figure out any schema around that. And Glue will exactly do that. And once you get that schema, you can always run an SQL query using something called Athena, and which comes under the analysis and processing part. Okay, so most of the time, this Glue and Athena we use together, because Athena is typically used once the Glue crawls through your data and come up with a table schema, and then Athena can just use that table to run some SQL query. Now, when it comes for processing and analysis, we have different services like Amazon Redshift, Elasticsearch. Redshift is predominantly used for data warehouse, and it is a columnar database. That means data is stored in columns, and that's why it is pretty fast, and you can run queries on that to fetch data from your data warehouse. And then we have different services like Amazon Elasticsearch or Amazon EMR. So speaking of Glue, it is important to understand how Athena works. So Athena is interactive query platform where you can just direct your S3 bucket, and it can just run some query based on the schema that was discovered by Glue. So no infrastructure needed. You don't have to load any data into Athena. It just reads the schema using Glue, and it will you can just run SQL query. And we are going to show you that in the demo part. So things will fall in place if it is very dry now. Because it's too much of theory. We have been discussing for last almost 30 minutes. So once all of these gets over, like a data source, ingestion, storing of data, then cataloging, and then processing the data and analyzing using Athena, ultimately you need to use this information to do some task or to take some business decisions, right? So it can be anything based on your requirement. It can be a machine learning task that you are running on a Jupyter notebook. So you can do all the analysis and pre-process all the data, and you can give that data to train a model on SageMaker. Or you can use your filtered data, analyze data, and showcase it in some dashboard using Amazon QuickSight, so that you can tell to your leadership or maybe the CXO level people that, hey, this is what our business is doing for last 6 months or last 1 year. I think this is the this should be our action plan for next 2 quarters from now. So QuickSight is a brilliant tool which you can use for dashboarding. In fact, it also has some inbuilt machine learning capability which you can make use of, on top of your data. Right? And then you have different third-party tools like Looker and so on. So I guess we discussed a lot about the theory part. So maybe I will hand it over to Rohini, and she will help you with few of the demos, which will touch base on few of the concepts that we have learned so far. And feel free to ask any questions. I'll look into the chat, and then we have one more demo towards the end. If time permits, I'll show it to you, or else we will discuss that in the next session. Okay, so let me stop sharing my screen. And
I did park one question for you, but it may need a little bit of explanation, so maybe we'll just take it later. I'll just share my screen. Let me know if you can see my screen.
yes.
Awesome. I can't see anything now, but great. Okay, so you can see my screen. Let me try and increase the font. So everyone, what we are going to do in this particular demo is I'm going to show you integration of 3 AWS services that Suman talked about, right? One is for storage, which is Amazon S3. We'll look at S3, we will look at Glue, and we will look at Athena. Okay, so what we are going to do is we are going to store our data in S3 bucket. So I've already stored that data. So I've uploaded a sales.csv file into this S3 bucket. Let me also show you what this file looks like. So there is a lot of data. This is a CSV file, and there is a lot of data in this file itself. Okay, that's too big, but it has certain column names, and it has lots of rows of data into it. Okay, so I've stored this into my S3 bucket as a storage platform, right? So now what I'm going to do is I'm going to use the service called as Glue, where I'm going to use this Glue service to crawl over the data that I've stored into this S3 bucket or this particular folder inside the CSV, and I'm going to ask it to create a database. Now, this is not really a database where you can go and query, right? It's more like a metadata information of what are the columns in this particular CSV file, and what are the data types of these different CSV files. And what we will do is we will use Athena to query this particular database. Now, let me show this to you in action. So what the first thing we'll do is we'll create a crawler. And before I go ahead, Suman, please do stop me if I miss some certain points out. It happens with me at times. So please do stop me wherever you feel I've missed something. So I've clicked on add crawler. And what I'm going to do is I'm just going to quickly add a crawler. Let's call it something like sales crawler. Okay, I'm not going to configure anything else. I'm just leaving it default for this demo. I'm clicking next. And what I want to do is, where is the source type for this crawler itself? So I'm going to use the data store. And where is this data store? So I'm going to use the S3 as data store. And I'm going to crawl all the folders or the new folders that is coming into the S3 folder. Suman, do you want to add anything here before I move on next?
Oh, that's perfect. Yeah.
Cool. So once you go there, what I've done is you can select a data store. Now in this demo, obviously we are going to select as S3, but you can select other data stores like Dynamodb from AWS or DocumentDB, or MongoDB was, I think, recently added as a data store as well. So here I'm going to use S3 as a data store. And you can see that if I'm using S3, I don't need to provide the connection. So I'm just going to leave it optional. And what I'm going to do is I'm going to specify the path. So let's specify this path. It's quite easy. I'm just going to click on this folder. And I'm going to find this bucket that I've created. So what is this bucket name? It's AWS Glue Women in Big Data demo. Okay, so let me just quickly find this. Okay, I found this bucket. I also want to go a bit deeper into it. So I can also click the plus sign and I can go deeper into which folder I want to do it, or do I want to do it at a bucket level or any folder level. So I just want to go and do it at the CSV folder level. Okay, so I'm just going to select, and it's again going to show you the path. Just check this. You can also exclude any patterns if you want, if you have more than one file or you have multiple kind of data structures coming in. So click next. Do you want to add another data store? So no, right now I just want to work with my S3 location. Now here, when you're doing it for the first time, you go ahead and add a name. So whatever name you add, let's say, for example, default or test or whatever, AWS will automatically create the IAM role. Now, IAM is Identity and Access Management service from AWS. It allows you to get proper permissions, proper access to your content, right? So in this particular situation, the IAM role will allow this crawler that I'm creating to run and access the data that I have stored in S3 bucket. Now, this is because the service is calling another service. It needs to have those permissions given to this crawler so that it can go and access this data. So what I've done is I've already created something. So I'm just going to go ahead and select this particular role. If you need more information on how to do this, if you don't want to do this like this, and you want to go and create, you can just find information here. Then you click next, and now I can select the frequency. Like, do I want this crawler to run on demand? Like when I say run, it should run, or do I want it to keep running hourly or daily, or what is the frequency? Now in this demo, what we have done is we just have one file that I've uploaded and I'm running a crawler, right? But in real life, what would happen, for example, if it's a log ingestion thing that you've defined, right? Your logs will keep coming, let's say hourly, or your logs are coming in every 15 minutes, but you want to just run this crawler maybe once in a day or once in an hour, because the data doesn't keep changing a lot. You want to just do it once in a day. You can set that, and it will automatically run this for that particular frequency. So you can set when do you want to do it and more information. As of now, we're just going to run on demand. Then I can also say, do I want to add any database? Now this is, as I mentioned, it's not really a database. It is going to be, it is not really going to be a database. It's going to be more like a metadata database that it has created. So what I'm going to do is I'm going to add a database. Let's call it something sales DB. Okay. Everything else is kept as optional, and I'm just going to create this database. Okay. And optionally, I can also provide any prefix I want. I'm just going to skip this for now. So in this crawler, I have given the information. I've given its name. I've told it where the data is, where is the data stored. So it's going to be S3. I've also defined the IAM role that it needs for the permission. What is the schedule, and where is the output going to be from the crawler? So when the crawler is going to run on this S3 bucket data, after it has completed, where will it go and finish the output? I'll just stop for a second if someone wants to add something here.
No, that's perfectly fine. So with this database is basically, it's a virtual entity, right? So it's not a relational database as such, right? So you can just think about it as a placeholder for the crawler, or rather for the glue, to just save the schema that it would read, once it starts the crawler. Yeah.
Awesome. So I'm just going to click on finish. I should have clicked on finish because it is going to take a bit. So the crawler has been created, And if anyone still wants to ask this question, what is a crawler? A crawler will connect to a data store, will progress this through the different classifiers that it has defined, and I'll just click on run. So let it run by the time I keep explaining this. So it is going to progress through your data with the list of classifiers that we already have, and it will determine the schema of your data, right? And it creates these metadata tables that we're just going to look at. Now, in this case, the crawler has started running, so it is actually going through the data store, the data that we have stored in this particular location. It is going through the entire data, and it is running a list of classifiers. I'll just pause because there's lots happening. Suman, maybe you want to add something, some more information there.
Yeah, sure. So in this, what is happening under the hood, as Rohini mentioned, right, that it is going to, scroll through all the data that we have in that S3 bucket or that path that is mentioned in the included path, and it is not going to understand the schema first place, right? So it uses something called Strade, and we use some algorithm internally, and it tries to figure out what is the table that what is the data is about, what are the column names, if it is a CSV file or JSON file or whatever. It tries to get that information, and then it doesn't just do one prediction. It does lots of different predictions, and whichever predictions come out with the maximum probability value, that only gets defined as the column name. And we are going to see that if you click on tables, I guess Rohini,
it's almost stopping, so I'll just go ahead and check out databases. So remember, I clicked sales databases. So here also you can go and find it. If you have too many tables, I find this easy to just go add databases. So what you can see is there is a table that in the tables, there is also already a table being created. The reason is because I gave the folder name as CSV. But you can see that this table has been created inside this database, the location, where is the data coming from. And sorry, Suman, go ahead. You wanted to add more info here.
Yeah, right. So this is the same thing which I was about to say. So if you see that we see the column names and the data types, and it uses Strade for discovering all these properties of this table. But the point is, this is not a one-time job. It has internally worked out with different options that it has predicted, and then these are the best prediction, and that is the reason you have the liberty to change this. So you can change the column name, data type, if you feel that the prediction that it has done, right, it's not correct. So maybe you can change the column type to binary or Boolean, based on your data, because not always maybe Glue would be able to detect the data type properly. But I haven't seen any time in last 1 year where it has detected anything wrong. But yeah, you have a choice as well, not only to change the data type, but also to change the column name. Yeah.
Yes, and you can see that it automatically picked up these from the CSV and added the data types, right? And we can also see more information on how many records, where is that, average record size, how many objects it found, and there is also some information on how many records it found in that particular CSV file. So you can find the record count. So this is where we used Glue to run as a crawler on this CSV data. Now let's go and check out the magic of how we're going to query this data, right? Now, remember, this data is in a folder in a CSV format. And what we are going to do here is we are going to Athena. Okay, I'm just going to manually refresh this table data list. I'm going to find my database that I defined in Glue. And you can see that it's already populated the table. If I want more information on different columns, you can also see here. But just as a simple query, you can now run select or SQL queries like select star from this particular database, which is and this particular table, and show me the last 10 columns, right? So here you can see that the data is not in any particular database, right? I've not used any SQL database. I've not used any NoSQL database. What we have done is we have just dumped the data into a storage location. And using Glue and Athena, I'm able to query this data in this location. Now, what are the benefits here? Is because this is just in a storage space, which is very cheap. Like if you try and search for AWS S3 pricing, it is like maybe $1, $2 for GBs of data, right? So the storage of this data is very, very cheap, and you can run queries on this data using simple interface, right? So here I can also give your other information like, hey, where sales is something greater than 5,000, please run this query, and this query should be executing on that data, and I will find that information, right? So this was a simple demo where we saw that how S3 Glue and Athena can be. Now let's go and make it a little bit complicated, right? As of now, we just saw crawlers, we saw databases, and we saw tables. Now let's try and convert this database from a CSV format into a Parquet format, okay? So for that, what we are going to do is we are going to use Glue again. But notice Glue has not only data catalog, but also ETL capabilities inside it, okay? So what we are going to do inside ETL, we're going to select the jobs section. And as of now, okay, I'm just going to close this. As of now, we don't have any jobs defined for the ETL work to be done, okay? So I'm just going to go ahead and add a job, okay? Let's call this, okay, I'm bad at names. Okay, let's call this sales CSV to Parquet format, okay? For this could be a use case where you're getting a lot of different log files or a lot of different data from different places, and you want to make them into one particular format, so that whenever you're going to go ahead and your next step in your analytics, when you're going to go ahead and process this data, it is in just one format for you to process, right? Then you would go ahead and select the same IAM role that I defined. Here I can define, do I want to have a Spark job? Do I want a Spark streaming job? Or do I want a Python shell? Right now, I just want a Spark job, and I can go ahead and select more, versions that Glue supports today for this particular job. I'm just going to go with the default one. And I'm also using a script that is generated by AWS Glue for this particular ETL transformation. If you want to use your own scripts, or you want to define a new script, you can also define it at this particular location. Okay, right now I'm just keeping everything default. Glue will go ahead and store it in S3 bucket. It has to store the script somewhere, and it has already created these buckets for me already. I don't have to do anything. So I'm just leaving everything default, going next. Okay, here I will select what is the data source. So my source in this case is the CSV file, which I want to convert into the Parquet format, right? So the CSV is my data source. The next one is, what do I want to do in this particular transformation? I want to, let's say, change the schema from the source to the target, okay? Then I would say, go ahead and create the tables in your target, okay? I don't want to update any tables. I want to create a new table. So here I'm again saying, I want to create the table in S3, and I want its format to be Parquet. Okay, so now I have option to convert this JSON into different formats, but right now I want to select it as a Parquet format. Then I can also give the target. Now in this case, what I'll do is I'll have the same bucket, but instead of the CSV folder, I will now select the Parquet folder. Okay, let me also show it to you in S3. So go to sales, you can see there are two folders. If I click on Parquet, there is no objects right now. Okay, so there is no objects or no files being created in any format. So I'm just clicking next. And here you can also see that if you want to change anything, or you want to add any more columns while this transformation is happening from CSV to a Parquet format, you can also add that information here. So you can add more columns, or you can, change the source, change the target here. So I'm just going to save this job, and okay, and it's going to also open the script for me to see. Now, if I want to do more transformations, I want to do more changes here, I can also do these changes. Like I want to change the naming structure or whatever here, or add more transformation script here, I can also do that. As of now, I don't want to do any of that. I'm just going to go ahead and run this job. Okay, it's going to give me some information. And what essentially Glue is doing in this case is, this is picking up the CSV that we have provided in the S3 bucket. It's going to run that job on it. It's going to convert that into a Parquet format and store it into this destination that we have provided. Right? As of now, there is nothing running here. So let's wait for the job to complete, and I'll take a pause if I've missed anything for Suman to add.
Yeah. So basically, the idea of this ETL job is, you can make use of your data, which is stored in S3, and you want to process that data. You can always come and use this Glue ETL jobs to create your own script. In this case, we are using the default script from AWS that comes up from the Glue ETL jobs. But yeah, so idea is you can convert or transform the data in the format that you want.
Yep. So it has already created the Parquet format. Now, I cannot actually download and view this Parquet format on my desktop, right? But I want to, again, try to run an SQL query or run some queries to see what data is in this format. So again, what we will do here in this case is, let's go to Athena. I'm just again going to refresh this. And here, now you see that it's no table being created, right? So let's go ahead and open Glue again. And this is going to be quick. I'm going to just do this quickly because I've already showed you how to create this crawler. So I'm just going to create a crawler called as sales Parquet. Okay, next. Here I'm just going to find that bucket where I have the Parquet script loaded. Parquet, select, go ahead, next. Selecting this. I'm going to run this on demand. I don't want to add anything, but I want to put it in the sales database and just click on finish. And this is again going to take a minute to run. So ideally, once this is done, there should be in this database, sales database. As of now, there is just one table called a CSV. We should have another table here for the Parquet file form. Right? Okay. So this awkward silences for me. If there were any questions you want to take, Suman, we can also take that.
Yeah, so we just got a few questions, I guess, we answered that in the chat. But, one of the advantage of this Parquet is, you get a better performance and you can save a lot of cost because it compresses the data and then it saves the data in a columnar format. So I guess, Rohini, if you can go to the S3 bucket and show the name of that file. Yeah, if you see this name of this file, it uses Snappy, so which is one of the form of compression engine, and it compresses the data in the most optimized way. So you don't have to use much of your storage in the backend. And since it is columnar, you can run queries and you get better performance because data is stored sequentially, in the form of columns, not sequentially in the form of rows, which is typically the case for any relational database. And here we are talking about data analytics. So most of the workload would be OLTP kind of workload where you will run through the whole data for whole items, right? And that's why we we try to convert the data into Parquet before we do any analysis. Yeah.
Interesting. So let's go and check. I think it should be done by now. Yes, it is stopping. So let's go and check the databases, the tables, and you can now see the Parquet table being created in this particular format. And if I click that, I can again find, yes, the record count is there. What is the file format? What are the different columns? If I had added more column, it would have been here in the schema. Everything looks good. So let's go to Athena, quickly refresh. And you can find Parquet here and just run the same thing, same query here. And that's it. Your data is again visible in this particular case as well. Again, if you want, you can do this, like 5,500 or 5,000, and you can run the query. and you can find the same data available just in a different file format. So that was me. That was my quick demo. Over to you, Suman, to showcase the entire. Thank you.
Okay, great. So first of all, I'm very happy that today we are almost on time on what we have planned for. So let's walk you through with another demo. But before that, let me first show you what is that demo is about. Okay, so let me first share my screen. Okay, so I hope you can see my screen. So what we are going to do now is we understand, we understood what is Glue. We understood what is Athena, how you can make use of Athena and Glue to run some SQL query on the data which is sitting on S3. So this part is, I guess, you are already familiar with now, this whole path, right, which Rohini mentioned in last couple of demos. Now, what we're going to do is we will just take few of the learnings that we had from Kinesis, and we'll try to see what are the features that we can make use of Kinesis and do some, real life application. Okay, so in this example, what we are going to do is we are going to take Amazon product review data. We have tons of data on the product review. So these are the reviews which you and me might have given at some point in time after buying or purchasing any product. Now, what we're going to do is the idea is once the data comes to AWS or Amazon, Amazon wants to read the customer feedbacks or customer reviews, and based on that, we want to put that as a summary in the product page. So you might have seen, if you go to Amazon.com or Amazon.in, you will see different star ratings, like in terms of durability of this product, longevity, and so on, right? So those all are not done manually, right? It's based on the feedback that we as a customer have given to Amazon, right? So in this case, we are going to stimulate that. So we are going to create a Amazon Kinesis data Firehose. Okay, so this is going to be the service that we are going to use for ingestion, where we will put lots of data, and those data are nothing but Amazon product review data. And within Firehose, we will see that how you can make use of Lambda to do some tasks. So we will trigger a Lambda function, which will ultimately use one of our AI service called Amazon Comprehend, which is an NLP based AI service for language processing. So the idea is, given us a review, we want to know that whether that review is a positive review or a negative review. So basically, we want to understand the sentiment of the product, the review. So once that comprehend, gives back the sentiment, let's say positive or negative, we want the data to go back to Firehose, and then in the whole data which was pushed here, right, we will be adding these new data, which is the sentiment, right? So ultimately, whatever is the final data, that means the data which we have pushed, that is the customer review, comments, and all of that, plus the sentiment. So we will add these two, and we will save this data in S3. Okay, and once it is saved in S3, you can always use Glue and Athena, just the way that Rohini mentioned in her demo, to analyze that. Okay, this product, let's say this product category has a very positive sentiment across APAC region, but it is not that positive in maybe EMEA region or Americas, right? So we may need to think about some other product promotion and in that region's customers. Okay, so that's the overall idea or the architecture that we are going to use for this simple demo. Now, one important question is how we are going to generate this product review data. So we are going to use Python SDK for that. Because this data is already there in our data repository or data set. You can just download that and get started from. You can just read the data and use the Python SDK to put in Firehose. Okay, so let's exit out from here. Okay, and what we are going to do is we are going to first show you the Lambda function. Okay, so what is a Lambda function? I guess this is something that we have not discussed so far, but Lambda function, you can think of it as a serverless service where you don't have to deploy your infrastructure, you don't have to create an EC2 instance or virtual machine to run your code. So you just have to write your code, and that code will be executed based on some trigger on the cloud. Okay, and who will do all the infrastructure creation and all of that? That would be done by AWS, or rather, AWS Lambda, which will create the runtime environment for your code. And once the code is executed, it will just destroy that environment. Okay, that's why we say it's serverless. That means you don't have to manage, all the infrastructure to run your code. Okay, so we are going to use Lambda, as we have just seen, to trigger the Amazon Comprehend service, because when we want to use Comprehend, only when the data is fed into Firehose. So that would be a trigger for this Lambda function. Okay, and what is Amazon Comprehend? Amazon Comprehend is an AI-based service, as I mentioned, where you can, if you give an English sentence or any sentence of different languages, we have a support of more than 24 languages. It can do a lot of things like entity detection, language detection, and one of the functionality that it has is to detect the sentiment. Okay, so let's first see this Lambda function, and then we will get into this Firehose. So if I go to Lambda and open it in a new tab, you'll see that if you have come to this page for the first time, you may see no Lambda function created, or you might see a different welcome screen, because since we have few Lambda functions here, so that's why the screen looks like this. But you can click on functions and then search for the function. So the function that we have for this is product review sentiment. Okay, now this is the function that we have. It's a simple Python code. So the idea is, in serverless, you are not telling AWS that which operating system, which EC2 instance, or which type of virtual machine need to be used to execute this code, right? So all you are giving is what is the runtime. So runtime, in easy words, is basically what programming language that your code is in, right? So that it can create that environment for you. So this is the Lambda function. So we are importing few of the libraries. So we are using Boto 3. This is the SDK for Python. So if you want to access any AWS-based resource from using Python, you need to use this SDK called Boto 3. So if your application is in .NET or Java or so on, you can use the respective SDK. We do have SDK for all these languages. Okay, and we are using base 64 module because the review that we have, it is encoded. So the review that will come from using Firehose will be encoded, right? So we need to decode that data before we send that data to Comprehend, because Comprehend doesn't know how to decode and encode the data, right? So because that's not part of the AI engine, right? So what we are doing is we are creating a function. Okay, and this, the function name is Lambda handler. This would be the typical function name for any Lambda function, which has two parameters, event and context, where event is actually contains all the information about that trigger. So in this case, the trigger would be whenever a review comes in, right? And context would be some metadata, like at what time this has come, where it is, and so on. So this context you may not use much, but this is an event is the most important thing for any Lambda function. So in case of, let's say you are writing a Lambda function where it should get triggered whenever there is an image file uploaded on S3. So in that case, this event will contain that S3 bucket name, that name of that, the name of that image file, and so on. Okay, so this is the this is the guy that we need to work on inside this function. So what we are going to do is we are going to read through all the comments or reviews. And you may ask, we are doing this analysis real time, so we can always process one review at a time, right? But since we are using Firehose and we know that Firehose has a buffer time of 60 seconds, that means it might happen that Firehose will have more than one review before this Lambda function get triggers, right? So in that case, we have to go over all the reviews which Firehose has already buffered, right? So that's why we are running a for loop, because it might so happen that the number of records is more than one. So here you can think of records are nothing but the product reviews by users like you and me. So we are looping around all the records, and we are decoding it because it's encoded. So we are decoding it using the base 64 module. And we are just reading this from record data hash. So if you ask me, how do I know about this exact data structure or exact dictionary? So the way that we do it is, you can just keep on printing that dictionary and try to see, what is the structure, and then, you can use the, right path. Okay, so it's not like, we can remember. So once this is decoded, we are loading this using JSON module. And once that data is there, we can format that, that whole string, because idea is we are going to send this text, the whole text to comprehend, right? So now if you go to any Amazon review, you will see, let me go out to any Amazon review so that you may get a better understanding. So if you go to any product, let's say this PC, okay, let's take this monitor, right? Now, if you scroll down, you will see all the reviews right here. If you see in this review, you have some text in the body and you have some title, right? And a few may have just star rating and not title or any body. So basically we have two texts. One is in the title and one in the body, right? So now what we are trying to do is, since we don't know which review will have what, we are going to concatenate this title and the body. Okay, so that we are always covering all the corner cases, right? When it doesn't have any body, or it doesn't have any title, or it doesn't have anything. So when it doesn't have anything, then there is no review. So we can always filter with a null value, right? I'm sorry. So here, what we are doing is we are exactly doing the thing that we have just mentioned. So we are just concatenating the headline and the review body with an hyphen as a separator. Okay, and this review is not nothing but is the actual review which we are going to send to Comprehend, because Comprehend is an NLP based model, right? AI service, and what it just understand is it just understand the language modeling. And the way that NLP works is, given a sentence, it will just take it as a piece of English text, or any text of respective language, and it will try to understand the context of that sentence. And it doesn't matter, it's the context is in the heading or in the body, right? So that's why we are just concatenating. And then we are creating and we are just calling sentiment, detect sentiment. And I guess I missed this client definition. So if you scroll up, we have created a client for Comprehend, because Comprehend is the service that we are going to use. And the way that you can define a client is like this: boto3.client.comprehend. So let's say if you want to access S3 in Amazon, using Python in your code, you can define something like this: S3 client equal to, let's say, boto3.client, then S3. So you can just make use of boto3 like this, okay, if you are new to boto3. So it basically creates an instance of S3 class. Okay, so we are going to use this client, which is nothing but Comprehend client or Comprehend instance. And then that has a function called or a method called detect sentiment. Similarly, it has different functions like detect entities and detect sentiment, then detect language, and so on, right? So those all are different functionalities of a Comprehend function or AI service. Now we are passing this text, so we are just passing the first 4,000 characters of the text, because we can understand the notion of the sentiment or the sentiment of the review if you just read the first 4,000 characters, right? And it's quite big, so we should be good. Then we define the language. So this is an English language. So we are just defining it. In fact, even if you don't give this, Comprehend have the capability to automatically detect which language your text is in, right? So, but let's not make the task more heavy. Let's define this, and then we are just printing it, in the so that we can see in our log what is the sentiment that that Comprehend is detecting. And then what we are doing is, if you remember, we mentioned that we are going to add the sentiment into our existing data, right? So that's what we are doing here. Our exact data was this payload, right? So we are just adding another key to this payload dictionary called sentiment, and we are just adding the value of the sentiment that we received from the Comprehend AI service. Okay, and once that is done, we are just using JSON to dump the data, and we are just returning this output record. That's all. Okay, so this is about the Lambda function. Now let's see that who will trigger that Lambda, because if you look back to this architecture, we have just gone through this Lambda function, but who will trigger this Lambda function, and how the data will come to Firehose. So we will see how the data will come to Firehose after some time. But now let's see the Kinesis Firehose configuration. Okay, so let's go to Firehose. So this is the Firehose dashboard. If you want to come to this page, you can just search for Kinesis. Okay, I'm not clicking because this it will take to a different page. But if you come here, if you click on Kinesis, you will come to this page, and then you can click on Firehose, or you can click on delivery stream. Okay, it's as the same. So we already have a customer review stream, but before we go there, let me show you when you create a stream how it looks like. So you can give some stream name, let's say demo. Okay, and then the first thing that you need to define is how your data is going to come. So there are two options. Either you use direct put, that means using SDK, or you feed the data directly, or you can use some Kinesis data stream. So you can connect some data stream to Firehose. Now, if you remember in the presentation, we have shown you this, right? So here is the Firehose, and the data is coming from Kinesis data stream, right? Analysis is just an online thing which you can just use on the ongoing data, right? Which is coming through Kinesis. So in this if you connect your data stream like this, in that case, you have to select Kinesis data stream, and you have to select your data stream here. I just have one data stream which is for some other project, but you get the idea, right? You can click here on to create a new data stream, and which will ask you to create a number of shards and so on, which we have just learned in the initial part of today's session. So you can do so, but for our example, we are going to use that Python SDK. So we are going to use direct put. And then you can do some encryption. I mean, we'll not go over that, but you can always use AWS key management service to create your custom keys, or you can use the default keys from AWS. So that's regarding the security side. So once the data is inside Kinesis, now there are two things that you can do. You can transform that data, and you can convert the data to some different format. Okay, so what do we mean by transform? That means you can invoke some Lambda function and do some transformation on your data. Okay, so in our case, the transformation would be read the data and add sentiment parameter to that, or sentiment attribute to that, and how we can add that sentiment attribute using Comprehend. Okay, so you should just think in those lines, like how we thread service. I mean, we stitch services to build something meaningful, right? So in our case, we are going to use this transformation capability using Lambda. So you can click on enable, and here it will ask you to select the right Lambda function. So in our case, it's product review, I guess, if I remember correctly. Yeah. So you can create the Lambda function beforehand and select it here, or you can click on create new, and it will redirect you to the Lambda page, and you can create one. Okay, and then if you have multiple different versions, you can pick the right version for the Lambda function, and it will automatically fetch the metadata of that Lambda function. This Lambda function is written in Python 2.7, and this is the runtime we need to have for this particular code, right? So, and after that, we can convert the data. So just like in Glue, when Rohini mentioned that and shown in the demo that how we can convert the data from CSV to Parquet, here also you can enable that conversion, and you can use Parquet or ORC. There are two data types that is supported. So for now we are disabling it, but this is one of the capability that we have. Then we can click next. So, but before we go to next, let's recap. We have defined the source, which is direct put, and then in the processing part, we are doing just Lambda invocation to get the sentiment, and we are not converting it into Parquet. Right? So now we can come down, click on next, and the last thing is we mentioned that if you look at this PPT from Kinesis data Firehose, you can put the data in S3, Redshift, Elasticsearch, Splunk, and few other third-party tools or frameworks. So here, exactly these are the destinations, right? S3, Redshift, Elasticsearch, some HTTP endpoint, and third-party services, which contains Splunk, New Relic, MongoDB, and so on. Okay, so for us, it would be S3. And since we have selected S3, we need to give some destination. That means we need to give some S3 bucket name. So you can give the bucket name here. Let's say we pick any random bucket name, and this is the bucket name where the data will be sent after processing. Now, we do have the capability where you can save the unprocessed data so that you can analyze it for later use in case any failure happened during the processing stage, right? So for that, you can define backup. So if you scroll down, you will see that you want to enable S3 backup or not. So this capability enables you to save the data in case any processing fails, and you can still go and investigate that data, okay, on S3. So in a nutshell, as a destination, when we define a S3 bucket for any Firehose stream, you have the capability to save the processed data as well as the unprocessed data and monitor the failures while doing the processing. Okay, so we can give some prefix like let's say process data, and let's say errors, maybe in errors, something like that. Okay, so we get the idea. Like you can partition your data across your S3 bucket for a better readability. Then you can click on next, and here comes that buffering thing which we discussed, that this is not real time, it's near real time. And the reason it is near real time is because you need to at least put a buffer of 60 seconds. That is the minimum time interval that you need to set. That means that you can analyze data which is there in the Firehose stream, but you have to wait for at least 60 seconds, or the buffer size. So let's say we put the buffer size as 1 MB, whichever threshold hits first, because 1 MB is the minimum. You can read the data from Kinesis. That means my Lambda function. What do we mean by read the data from Kinesis? If you look at this slide, the diagram, this Lambda can read the data from Kinesis only after 60 seconds, or once it reaches 1 MB. That is the reason in the Lambda function we wrote that for loop, so that in case a multiple review comes, it can read through all the reviews. Okay, and then we can have some compression engine, and this is a snappy. If we have used in the previous screen, if you have used Parquet as a data format, it might be a good idea to use Snappy as a compression engine, because these two works pretty well, but you can disable it as well. And then you can put S3 encryption in case you want to encrypt the data on rest on S3. And again, error logging, these are standard things. And obviously you need to give some permission, because Firehose need to read data, write data on S3. Okay, and then you click on next, and you can just review all of this and click on create delivery stream. We are not going to create that because it takes some amount of time, but this is exactly what we have done in this customer review stream. Okay, so if I click on this, you will see that we have defined the source as direct put Python SDK, And if you see here, it is direct put Python SDK. We are going to use that. And this is the Lambda function that we have just seen. And that's all. And we will use this AWS Glue Suman S3 bucket where we will be having all the process data. Okay, so and now the last part that I want to show you is how we push the data, right? So again, let's go back to the slide. How we are going to push the data using Boto3 SDK, right? So the way that the place from where we are collecting all of these data is from here. This is the Amazon review dataset. You can come here and read about it, and you can download it. So this has different products like camera, toy, and so on. And we will pick one of the product and then read the review because it has lots of data. So the way that we are going to do this is using a Jupyter notebook. I have a Jupyter notebook. So don't worry about this Jupyter notebook. You can run it locally in your laptop as long as you have all the packages installed, or you can run it on SageMaker. So SageMaker is an AWS service wherein you can create a Jupyter notebook. And the advantage of having that Jupyter notebook on AWS is you get all these kernels already preloaded and installed, like PyTorch, MXNet, Chainer, and so on, right? And TensorFlow, obviously. So this is the advantage, and you can do a lot of things because since it is in the AWS environment, it has a very tight integration with other services. So we are not going to make use of all of that in this particular demo, but I would always encourage you to look into SageMaker. And this is the SageMaker homepage. Come to Notebook and select create a notebook instance. And once you create, you can just click on open Jupyter notebook, and it will open up just like any Jupyter notebook in your laptop when you install it locally using Anaconda. Okay, but if you're new to Jupyter notebook, just forget about it. That is not the focus of this particular demo. Okay, so the first thing is we are going to download few of the libraries, and then we are downloading this data set, and this data set is of camera, and then we are reading it through Panda data frame, and we are reading it through read CSV function, and we are just doing some data analysis. We are seeing that there are more than 180,000 rows. It has 15 columns. Now we don't need all these columns, right? What we need is review headline and review body. Rest all data we don't need. So that is what we are trying to do here. We are just saving the review headline data and review body. We are doing some housekeeping by removing few of the tabs and a few of the extra characters which has no use. And then comes the real part where how we are going to push this data to Firehose. So first thing before we read through this line of code, we need to know what is our Firehose stream name, right? So if you scroll up, our Firehose stream name is customer review stream. Okay, we can copy this in our clipboard, and we can come here because we are going to need that now. So again, we are creating a session called a boto3.session and then the region name. By default, it would be as per your configuration in the AWS CLI. But since I'm doing it in Jupyter Notebook, I'm just defining the region. Okay. And here we are creating a client, session.client. Previously, in the Lambda function, you have seen boto3.client. So what is the advantage or disadvantage, or why we need to use session.client versus boto3.client? So when you do session.client, it's kind of a, if you're aware of inheritance, right? So it is taking all the information about sessions into this client object. So it will have things like what is the region name and which bucket to use, who is the user, and all of that, whatever I have saved in this in this session. Okay, whatever I have defined. So that is the scope, so which gets cascaded or handed over to this client object. So we are creating a Firehose client object, and then this is the customer review stream, and we are just putting the stream name here, and here we are running a for loop. So what we are trying to do is we will just read 200 lines of this data frame right? And we will just push it to Firehose. And the way that we can push is we can use the put record method of on top of this client Firehose. So client Firehose is our client, which is a Firehose client, and we are using put record method, and we are defining the delivery stream name, which is nothing but customer review stream, and we are just passing the payload, which is a simple data that we have saved in the data frame. Okay, and we are using this regex so that we can put the payload data in a right format. Okay, so we can run this. So let's say I run this now, and what it is doing is it is putting 200 records into that stream. So we can again run it. It will again put 200 records. I can again run it, and it will again put 200 records. So why we are doing this? So that we get to that threshold of 1 MB, or we can wait for 60 seconds, whatever it is. Okay, so now if you come to this Lambda function, or even you can come to this customer review stream, and if you come to monitoring, and this is the Cloudwatch is the service that we have, which helps you to monitor the activity around your services or your resources that you have in your environment. And most of the services that you will use or encounter will have a Cloudwatch integrated. So we can click on Cloudwatch, and here you can see whether the function has triggered or not, or what is going on. Okay, so let's wait for some time. Okay, so we will go to this Lambda function. Okay, and we can come here to this and click on Cloudwatch. Okay, so the reason that we will not see those messages here is because if you see the architecture, if you see the Cloudwatch event for this, you will see the data stream information, like data is coming, but you won't be able to see what is the output of comprehend, because that will come in the Lambda Cloudwatch events, right? Event monitoring. So that's why we just came to Lambda, because we want to show you, what is the sentiment, because we have used some print statement in our Lambda function, right? So that is what we want to see. So if you just come to the code, and if you see, we have used some print statements, right? Print sentiments, print review, and so on. So let's go to the Lambda functions Cloudwatch event. And if you see that this is, I guess this is the event 531. So this is the log stream for that. And if you see here, you will see all the comments and its positive or negative reviews. Okay, so that's how you can make use of Lambda to process the data, and that data will be saved on S3, right? So now if you go to S3, I'm not very sure if I've opened it anywhere. So let's go to S3, and we can go to the same bucket, which is, I guess, glue Suman. And if you come to product review, 21/04/26 is the date. So this is hashed with the date and time. So it's you can run a query easily, because this has been partitioned with the date, and then you can see, let's say 12, and then you can open this. So this is the file which got processed. So this file should have that sentiment column, right? So that's what you can do with when you use Kinesis along with Lambda and Comprehend. Okay, so what you can do is you can take it forward, and now we can create a glue crawler. Okay, so let me see if I already have that or not, or else I will create, because we have already shown you how to create a crawler multiple times. So I don't want to waste your time on that, but let me see if I have that crawler or not. Okay, so I guess we have that, or I have deleted this. Let me see. Okay, no, this is not the file. So, okay, let's create one crawler. Okay, so again, we can come to this customer review Firehose stream, come to the details. And if you scroll down, you'll see that where we are saving this S3 data, we're saving it under AWS Glue Suman, right? So let's go to Glue. We can add a crawler, give some name, let's say my crawler. Click on next. Next, we can define the S3 bucket. That would be product review, right? Inside that we have this data. So let's select this and click on next. Next, and we can give some IAM policy, IAM roles. I'm sorry. Click on next. Select on demand. To create one database. So let's say my demo DB. Create one. Click on. You can give some prefix, or we can leave it as it is. Let's leave it as it is, and click on finish. So this is my crawler which I've just created. So let's run the crawler. So it will take a couple of minutes. So if you have any questions that I can take in the next couple of minutes, you can see the chat. Okay, so we'll wait for some time. Let's give 30 more seconds. So what it is doing is now again the same thing, right? It is going to that S3 bucket, it's trying to crawl, trying to understand the schema, and then you can use that schema to run some SQL query using Athena. Okay, so if you look at our architecture, we are at this stage. Once this is done, we can run some query using Athena. Okay, and if you want to learn more about Comprehend, you can go to Sage. Let's say you go to our homepage, and you can scroll down, come to the machine learning section, and you can click on Comprehend. Okay, so this UI is good to start off with, but later on you can use CLI or any SDK to play around. Okay, so you can use Comprehend for text analysis or natural language processing activities or tasks. Okay, you can click on launch Amazon Comprehend, and you can give some data, and then you can analyze. And once you analyze, then you will see that there are a lot of results has come, right? So it has detected the language as English with 98% confidence. You can see the entities like name, then company name, and so on, right? So there are a lot of things that you can do with Comprehend. One important thing is it also identifies the PII, the personal information, so that you can mask that before you put that data to someone else for in your data pipeline, right? Because you don't want to mask, you don't want to use the data with real like you don't want to pass a data with personal information of someone's, right? Like credit card numbers or date of birth and so on. So you can use this to identify the PII information within the text and mask it with, let's say, XXX or so on. Okay, so let's go back and just see that if the glue is done or not. So let's go to tables. Okay, so let's go to crawler. Still running. Still going on. So Okay, it's still in running phase. So it's still running. So let's wait for some time.
Let it run for a while.
Yeah. I'm just wondering if we have any data in the past. Because we did a couple of times. So it's taking, usually it doesn't take this much time.
Meanwhile, let's see if we have any questions.
Yeah.
But let it run. I think you answered a lot of questions. There was one out of context question, but if you have time, you can answer that now.
Okay.
Someone asked, could you explain what an ENI is? ENI.
ENI, is it a Elastic Network Interface or which? Because the ENI isn't.
I think EC2 related ENI. Yeah.
Okay. Okay. Yeah.
Elastic Network Interface. Yeah.
Yeah, right. So that's a virtual interface that you have when you when you connect your EC2 instance, right? So if you see EC2 instance is a virtual entity, right? So you create a virtual instance, and then if you log into that, you will see, once you log into the console and once your EC2 instance is ready, you will see that there is a public IP which you can go and access, right? But if you log into that EC2 instance and if you run IP tables or IPA or if config, whatever it is, depending on the operating system, you will not find that IP address, that public IP address, which you have used to log in. Okay, so the way that in AWS we mask it is the IP address is not attached to your instance, okay, because it's always dynamically changes when you terminate the system, when you create restart it or pause the system and again restart it. So it might so happen your public IP might change. So we attached an elastic interface, network interface to your EC2 instance, which you can use to log in to the EC2 machine. Okay, so that is how basically it is used, for accessing your EC2 instances.
Okay, great. So do you want to check if that job is done? I'll take the other question. Thanks, Suman.
So if you see now, now it detected the table and you see that there is a new field called sentiment, right? So now that this table is there, you can go to Athena. Okay, and you can come to the database, my demo database, and you see that this is the partition, right? Sorry, this is the table, and you can see the preview. Okay. And you see all the data with the sentiment, positive, mixed, negative, and so on. Okay, and then you can always use some where clause to see sentiment is positive or sentiment is negative, whatever, right? So that's the whole idea about how you can connect different services, integrate AI capability into your pipeline and make some business decisions based on your analysis. In fact, you can take this even further. You can connect this Athena data to QuickSight, and then you can create a dashboard and use some pie chart to see, which are the regions where you have positive review, which are the products that has positive reviews, what is the market, whether it's a US market or EMEA or whatever, and you can just channelize that information to the leadership in the right format. Okay, so that's about it. I guess we don't have anything else, but before we close our day, I just want to share one small thing is in the next session, we are going to have an AWS hero who will be sharing some insights about data engineering on AWS, and surely we'll have some demo. And if time permits, we will also show you one more practical use case where we will show how you can make use of data analytics or Kinesis for game development. Okay, so where we will be using some game telemetry data, and we'll try to see that how we can make use of that data using Kinesis to make your game development even better. Okay, so we will give you some more context, like if you have used any of the video games, you will know that there are different stages, and using Kinesis, you can understand at which stage a player death is occurring, more, so that you can make some changes in that level. Because if everyone in your user or everyone in your customer base are not able to cross that particular level, they might get frustrated and they might uninstall your app, gaming app from your mobile, from their mobile or laptop, right? So you don't want that. So you can use Kinesis to analyze your telemetry data from your clients, and you can take better decisions to make your game even more interesting and engaging for your customers. Okay, so this is just a heads up about the next session, but feel free to reach out to us for anything related to the topics that we have discussed today. And if you want to go deep into any of these services or any other services related to data engineering, just feel free to ping Rohini or me. We will try to see that how we can host one more session on that. Okay, so with that, I'll hand it over to Rohini. Maybe if you want to add something before we hand it over to the organizer.
No, I think you did cover it all. And yes, this has been part of a series. So if you have missed something, please do check out the earlier videos, and do try these things out if you can. If you can get an account, then you can play around with these things. And then, for the next session, then you will be much, much well prepared. So yeah, that's me.
Okay, perfect. Thanks, Rohini. So back to you, Ankita, and the team. Yeah.
Thank you, sir. This was a really great session, and I'm sure everyone enjoyed it. I have a request. Please fill the feedback form that I have shared in the chat box before leaving. And do check out our social media handles to stay updated about our future sessions. And do connect with our speakers at LinkedIn. I have shared their links as well in the chat box itself.
I would just like to add that I would also like to thank, the whole team would like to thank Women in Big Data and the co-directors of Women in Big Data India, Soumya ma'am and Dr. Ekta ma'am, for arranging this talk and providing us the opportunity for hosting it. Thank you so much, ma'am.
Thank you for the opportunity as well.
Yeah, thank you so much. Yeah, bye.
Thank you so much, ma'am. Thank you so much, sir.